You're back. Sweet. So, data types. A data type is a category for a particular type of data. What in the hell am I talking about? Think about it as categories, right? We have trucks, we have cars, right? Those could be categories, right? Different categories of like automobiles. Well, the same is for any programming language. We have string data, which is basically an ordered sequence of characters. What do I mean by that? Well, if we go back to variables, we're going to define a variable, and this variable is going to be called first name, right? We're going to do an equal and then provide a string data. And I'm using quotes. We can use single quotes, double quotes, right? And we can say this is John, right? So John is the name of a person. But in this context, John is string data because we have it encased in quotes. So if we were to create another variable, and we'll just be very imaginative right now, I think that was a made-up word, var1 equals 1. Right? Now, since we're working with string data, we can tell by it being enclosed with quotes. String data can contain any sequence of characters, right? So that would be a valid string. We could come in here and we could do like 100%. That would be valid. We could do 2.6. And that would be valid string data. We could even do some other characters like pounds or hashtags, right? That would be valid data. Or excuse me, a valid string data. Why? Because we have it encased with quotes. We can even do what is considered an empty string. Nothing inside of the quotes. We can also do integers, right? An integer is data consisting of a number without a decimal point. So if we were to do var3 equals, and we're doing an integer, so let's do the number 3. Right? That would be considered an integer because there is no decimal point. And as you can tell, we did not encase it within quotes. That would be a valid integer even if we did a negative number. That would still be a valid integer. The next, if we were to find another variable, would be float. Float data is data consisting of a decimal point. So this would be a valid float. This would also be a valid float, along with that, and even a negative number. So the main thing with floats is that it contains a decimal and not encased in quotes, right? So that is float. The next would be Boolean. So if we were to do another variable, we can say var 5 equals a bool value or Boolean value. And Booleans are either true or false. That would be considered a Boolean data type. And of course, it's not encased in quotes. Next could be, let's cover list. List data represents a collection of data. This collection can be any data type, like strings, integers, floats, booleans, or even other lists. So if we were to define a variable, we'll call this list1. And list1, let's say, is going to contain a first name, and as you can see, how we define a list is with square brackets as such, and then in between the square brackets, if we're going to add another element, we will do a comma. So we're going to do comma. Let's say John's age is 20, and we're going to include another list in here. So let's define list A equals, boy, what should we have at list? Let's say his last name is Smith. So we can do list A. And if we wanted to see the results, we can do print, and we're going to print list1. And let's run that. I will take the breakpoint off. We are going to run, and we can see the results down here. We see John, right? We see 20, and then we see list A, which list A contains Smith. So that is a list, right? Next up, let's work with dictionaries. Dictionaries are very common. A dictionary is a data type that consists of a key and a value pair. Each key is mapped to that value. So if we were to define a dictionary, we'll give it a variable name, then we will say equals, and it will be the curly brackets, right? So that is a start of a dictionary. Then we provide a key, and let's say our key is going to be named first name, right? And then first name is going to be equal to the name Jack, right? So the first name is Jack, and we're going to add another element to our dictionary, our key value pair. So we need a comma, and then let's do last name. And I am forgetting to encase the keys within quotes. So it is your key, and then colon, then the value. And in this case, let's say Jack's last name is, you got it, Smith. It's a very large family. So that is a dictionary, right? And if we wanted to see the results of the dictionary, we can do print. And what do we want to print? We want to print that dictionary. And if we were to run it, we will see the results. And we can see first name, we can see the value of that key, which is Jack. And we'll get more into how to work with these different types as we progress along. But this is just a very high-level overview. And another data type that you'll see would be tuple. So a tuple is a collection of data very similar to list. It can contain pretty much everything that a list can contain. The big difference between tuples and list is that a tuple cannot be manipulated. So once you define a tuple, anything inside that tuple will not change. So as we will see, we will define a new tuple, and this tuple will start with parens, and we will give it a value of 2. To add another element, let's do a comma, and let's provide Jack, and let's also give it a Boolean value of true. So this would be defining a new tuple, and these are the values. And if we wanted to see the results, we can do print, and we can say print tuple 1. We run it, and bada bing, bada boom, Bob's your uncle, right? So at a very high level, these are the Python data types. There are a few more, but mostly this is what you will be working with. These are the very primitive data types that Python has. One thing that needs to be mentioned when working with variables is that within Python, they are case sensitive. So if we were to define var1 and give it a string data type, and then do var1, which is all lowercase, and then give it a number, these two variables are different. And we can see by, let's do print, we'll do uppercase var1, and then we can do print and var1 all lowercase, and when we run this, we will see the output. Here, let me do this again. That's not. There we are. That's better. We can see the difference, right? So keep that in mind as we progress.